In this video, we are going to look at matrices. Matrices are a collection of data elements arranged in two-dimensional rectangular layout. Matrices are built out of vectors. So most of their properties are same as vectors. However, they must follow few basic rules. All elements of a matrix are of same data type, and all columns of a matrix must be of same length. In R, by default, all matrices are constructed column-wise. So elements are filled starting in the upper left corner and running down the columns. So let's go to the RStudio and create the matrix. We can create a matrix using matrix function. We will have to specify the values to be filled in the matrix and number of rows and columns to make the matrix. So here is a matrix function. We are going to fill in with first 6 numbers as the matrix elements. The number of rows are 3 and the number of columns are 2. After running the command, we can see that the matrix data type is created and there are matrix elements. Since matrix is filled column-wise, we can see that the elements in the matrix are arranged column-wise. If we specify the vector of values and one of the dimensions, the other one will be calculated automatically from length of data and other dimension. So here, number of rows in a matrix multiplied by number of columns in a matrix is equal to the number of elements in a matrix. With this formula, if one dimension is specified, the other one gets calculated. Now in this case, we have specified the number of rows equal to 3 and R has calculated the number of columns based on the formula. We saw by default matrices are filled column-wise, but if we prefer to construct it row-wise, we can send by rows equal to true parameter. Now in this example, the matrix is filled row-wise. So we are specifying the parameter by row equal to true. So let's execute this and you can see the matrix is created row-wise. Now please note here that the position of the matrix elements is changed since the matrix is filled by rows. Have a look at these two matrices, the one filled by rows and the other one filled by columns. You can see that the elements of the matrix positions got changed. The matrix elements are also recycled. So if the dimension of the matrix is more than the number of elements of a matrix, here for example the dimension is 2 by 4, 2 rows and 4 columns. So this matrix can have 8 elements in it, but the number of elements specified is 6. So if I execute this, then R will give us the warning. But have a look at this last column. The last column is filled in by the elements of the first column, which are recycled to match the dimensions of the matrix. We can use cbind and rbind functions to create a matrix. So let's create the two vectors m1 and m2. Now here I'm going to use a cbind function to create a matrix. Cbind function basically transposes the vector. So here m1 and m2 are transposed, they are turned into the columns, and these two columns are joined together to create a matrix. In case of a rbind function, it's straightforward. These two vectors are simply stacked over each other. But if you see the difference between the cbind matrix and the rbind matrix, you will find out the dimensions of these two matrices are different. In case of a matrix which is created by cbind function, we will have 3 rows and 2 columns. But in case of a matrix created by rbind function, we have 2 rows and 3 columns. The matrices can also be named. We can give the row names and column names to the matrix by using the row names function and column names function. Now here I have created a matrix which has the product sale values for two products, product A and product B, and for two different geographies. So let's create a row names and column names, and if I execute this matrix, you can see that the columns and the rows are named. Super. So in this video we created a matrix. In the next video we will subset the matrix. That is, we will extract the elements from the matrix. I will see you in the next video.